Salam guys. Salam guys. LEMPTOIS today BECL2 BECL2. So I will go through based to the LEMPTOIS. As you all know, what is it, a LEMPTOIS? So this is the Lewis structure, and then this one is the molecular geometry, polarity, type of hybrid, orbital overlapping, intermolecular forces, and the last one is the solubility. Alright, so the first thing, the Lewis structure. Okay, as you all know, so the first step, you must know the position of the element. There is in the BACL2, there is BE. BE is position for the BE is group number 2, and the period is number 2. And then, right, so from here you can write down 2 electron. Meanwhile, for the Cl is group 17, and then the period is period number 3. Alright, so group 17 is means 7 electron valence, and then BeCl2, there is 2 mole of Cl, so you will put it here 2, just time it to 2, yeah, you will manage to get 14 electron, and then the total 40 electron plus 2, yeah, you will manage to get 16 electron. Alright, this one we want to set up the Lewis structure, and then alright, so the electron is 16 electron. So secondly, you will draw the central atom Be, of course. Why? Because less electronegative if compared to Cl. Alright, Cl will be your terminal atom. Alright, and then create the body pair each. So body pair each is mean you already use 4 electrons, so minus 4 here, yeah, the balance will be 12 electron. Alright, so the next one, you will make sure, or you will attack the terminal atom. So Cl 1 2 3 4 5 6. You can use with the cross symbol or dot symbol for the Lewis structure. So now I use the cross symbol. Alright, so 6 electron I use for DCl, and the other Cl 1 2 3 4 5 and 6. So total 6 times 2 is 12 electron. So minus 12 electron is mean all the electron I use it for the drawing the Lewis structure. Alright, okay, so LEMPTOIS, so Lewis structure done. Alright, we go to the next one, that is molecular geometry. Okay, molecular geometry. Okay, so molecular geometry, Be, Cl, and Cl. So the molecular geometry for this one is AB2. Right, it mean linear. The basic shape is linear, and the molecular geometry also linear, and then the bond angle is 180 degree. Alright, so done about the molecular geometry. Okay, next one. Okay, before, okay, so LEMPTOIS, this one done. Molecular geometry done. Okay, we go to the polarity. Alright, so how about the polarity? BeCl. Okay, before you wanted to state whether this molecule is polar or non-polar, please make sure you use the molecular geometry, not the Lewis structure shape, but the molecular geometry shape. Alright, between Be and Cl, which one is it more electronegative? Of course, Cl is more electronegative, right? So you draw the bond dipole towards Cl, and then the other one from Be go to Cl. Okay, so this one you can see this is the bond dipole. So the bond dipole can cancel each other, alright? And then symmetrical arrangement and equal magnitude. Okay, equal magnitude because Cl and Cl, and then symmetry arrangement. So you can say the bond dipole can cancel each other, and then your mu is equal to 0. It means BeCl2 is one example of non-polar. This one is molecule, right? Not ion. Molecule. Alright. Okay. So for the LEMPTOIS again. So part of the Lewis structure done. Molecular geometry done. LM. Where is it? My P. This one. P. The polarity is done. So we go to the next one. That is tie of hybrid. Okay. Tie of hybrid. So tie or hair break. So this is your BeCl. Okay, so firstly we want to guess. Guessing the tie hybrid for the central atom. So bond pair is mean sigma bond here, sigma bond here. Is mean sp. So I guessing the tie hybrid for the beryllium or for the central atom is sp. This is my guessing. Alright, my guessing. Tie hybrid is sp. Alright, so I will give an evidence. So I must give the evidence like this. So the tie hybrid sp. Write down the ground state for beryllium. Alright. So beryllium is group number 2, and its period is number 2, right? So this one is 2s and this one is 2p. So group number 2 like this. Alright. So this is the earlier state or the ground state for beryllium neutral. Alright, so the next step will be excited state for beryllium. So 2s and 2p. So one electron from 2s will jump to 2p. Alright, that is the excited state for beryllium. Then the last step is once you already done the ground state, the excited state, so the last one is the hybrid state of beryllium. So sp. We earlier we already guessing that the tie hybrid for the central atom is sp, right? So that is the hybrid between orbital s and orbital p, right? Leave it 2 more. The 2p is anhybrid orbital, so you can state this one is anhybrid orbital. Anhybrid 2p orbital. Alright, done. Okay, so ground state beryllium like this, excited state, and then go to the hybrid state. So state. So you can say uh, the hybrid type average type sorry. So you can say that the type hybrid for the beryllium is sp. All right, done. Okay, so we go to the next one. So LEMPTOIS, Lewis structure done, molecular geometry done, polarity done, type hybrid done. Okay, we go to the orbital overlapping. Alright, so orbital overlapping for the BeCl2. Okay, so we draw this one, right? So Be and then Cl here, right? And then the other one Cl over there. Alright, so the electron must put it the electron and state sigma bond, and then before this we already know that the type hybrid for the beryllium is sp. This one also sp, right? So you must write down the type hybrid for the beryllium. Alright, so you can say that two sigma bonds form when sp of sp hybrid doing guys. Okay, so sp hybrid of beryllium overlap with Cl period 3, right? With 3p of 2Cl to form 2 sigma bond. Alright, done. So the lastly you must explain a little bit about the overlap between the beryllium towards Cl. So the explanation will be sp hybrid of beryllium will overlap with 3p of 2Cl to form 2 sigma bond. Yeah, we managed to get fully marks here. Alright, and then Lewis structure done, molecular geometry done, polarity done, type hybrid done, orbital overlapping done, and then I is intermolecular forces. I and F, intermolecular forces, right? So earlier we already know that the polarity of this one is, what is it, a non-polar molecule, right? So once you detect that this molecule is non-polar, so you can say that between BeCl2 towards other BeCl2 only weak when the wall forces. Forces. There is London forces. Between BeCl2 towards other BeCl2, there is London forces. Alright. And then how about the last one? So LEMPTOIS Lewis structure done, molecular geometry done, polarity done, type hybrid done, orbital overlapping done, intermolecular forces already done, and then the last one is the solubility. Alright, so you already know that this molecule is non-polar molecule. Non-polar molecule. It means if this molecule wanted to soluble in water, this the molecule must have or can form hydrogen bond. Right now between BeCl2 towards other BeCl2, BeCl2 only London, right? London forces. So there is no hydrogen bond. No hydrogen bond. It means cannot form hydrogen bond towards water. So insoluble in water. Okay, so cannot lah. Cannot form hydrogen bond towards water. So insoluble in water. Alright. Okay, guys. So perhaps you all understand about the uses of the LEMPTOIS table. LEMPTOIS table. So LEMPTOIS table. So each molecule that you want to draw its Lewis structure, you must follow this table. You must know how to draw the Lewis structure. That is the first step. The second step, from the Lewis structure, convert it to molecular geometry based to the valence share electron pair refraction. Alright, and then after you done for the molecular geometry, so you will do the polarity. That is the next step. The polarity of the molecule, is it polar or non-polar? Is it the bond dipole can cancel each other or not? Alright, and then you will do the next one, that is the type of hybrid for the central atom. And then next one, the orbital overlapping. And then from this one, intermolecular forces. Intermolecular forces, you take a look about the polarity. Alright, so intermolecular forces will be your number 6, and then the last one is the solubility. Okay, of course, for the polarity also. Alright, guys, so I think I stop here. A little bit explanation about the LEMPTOIS table for the BeCl2. Okay, guys, bye bye. Thank you.